All right, welcome everybody to week 8, day 2. First couple announcements. Loop's competence exam take 2 is up. Look for more competence exams coming in the near future. Second thing, you should be grinding away on your RPG assignments. I've been getting a lot of questions recently as to how you can collaborate with your teammate on your RPG assignment. The basic answer is use Discord, share your screen. One person talks and describes the code that is to be created. The other person is an intelligent typist that will type in what you say. It is a trap to fall into to allow one person to code and the other person to watch. That's not what you want. What ends up happening is the experienced person does all the coding, the inexperienced person goes to sleep and learns nothing. When you do pair programming correctly, what you want is one person describing the code, make a for loop that goes from 2 to 20, and then the smart typist, the person on the keyboard who's streaming, is going to say for int I equals 2, I is less than or equal to 20, I plus equals 2, that kind of stuff. And then alternate every 10-15 minutes, switch. And take turns being the person who's typing, and take turns being the person who is writing the code verbally. And if you're going to be like, well, how do you edit the same file? If you want, you can share your username and password. I don't recommend it. You can. There's a better way of doing it, and I'll go over a couple of them here. Cloud9 I haven't used in a while, so I can't really tell you too much about it, but I believe it does pretty much the same thing as what I'm about to show you here with Code Anywhere. So Code Anywhere has a 7-day free trial, so if you sign up now, you'll be able to have the trial go through the end of the RPG assignment. What you're going to do when you log in is, first thing you're going to do is you are going to create a new container. You just make a blank container, that's fine. Second thing is you go to connections, and you're going to create a new connection, and that connection will have the host name of the server, www.csci4x.com, your username and your password typed in. I'm not going to open it up because it shows the password in plain text and not stars or anything, so I'm not going to open that. But yeah, username, password, and host name. And then when you go into your containers like this, it's open, okay, open IDE. Sometimes you have to start it if you haven't run it in a while. It creates this IDE window in a browser. IDE stands for an integrated development environment. An IDE and a text editor are very similar superficially, but an IDE has things like a folder window over here that shows you all the different files in your folder, and it's got a compiler and a debugger and all these other things built into it as well. So a lot of people consider an IDE like a complete, it's called an IDE, an integrated development environment. So you can like run your program within it, right? Whereas with Vim, you save it and quit out and run it. Technically, you can run programs inside of Vim. Technically, you can install plugins and things like that inside of Vim as well. And, so, it's at a certain level, the distinction is academic. But whatever. So Code Anywhere has a online web browser based IDE, and if you click down here to connections, then you can see that it has csci4x here, and when you click on that, it will connect you to the server, and then you can edit files on the server just like you edit files using PuTTY. Okay, so if I were to say come over here to main.cc and click on it, it will open up main.cc, which is currently empty because I just made a new file. So you type include iostream using main space std, main open close parentheses, cout, hello world, and hit save. Okay, and then it's saved. And then if I close out of this and open it up on PuTTY, I have main.cc open here. Notice that it doesn't refresh automatically. You have to quit and reload. It will show the code that I just did on Code Anywhere. So am I suggesting that one person be on Vim, one person be on Code Anywhere? No, I'm not. If you're using Code Anywhere, you should have both people on it. And Code Anywhere has a collaboration feature. So if you've ever used like Google Docs or anything like that, you know how you can invite people to collaborate on your documents. Same thing. You can collaborate with your partner. You send them an invite, and then they can edit the code at the same time as you. You can chat with them and stuff like that. But you should probably be on voice chat anyway on Discord. And so that's a way that you could cooperatively edit a file together on the server without having to share your username and password, which I would personally feel uncomfortable with. But you do you. So that is that. And then in addition to Code Anywhere, there is Cloud9, which again I haven't used in a while. So I think it has the same features. Code together in real time, yeah. And it can connect to a Linux server that supports SSH. So it should work about the same way, as far as I know. Don't quote me on that. Code Anywhere will work though. A lot of students use it. Okay, so that is the announcements phase of today. The topic for today is a pretty important one, and it's the notion of two people can work on the same file at the same time. Yeah. So the notion is if you're given a complicated assignment, how do you break it down? How do you break down a complicated assignment so you don't have to code everything at once? If you've got to do something that's got a lot of different steps and functions, calling functions, which ones do you code first? Which ones do you code last? That's a big topic, and it's a thing that comes with experience. But in general, there's two different ways of approaching a big problem. There's two big approaches to breaking down big programming assignments, or big programming problems, really. So in real life, they're not, assignments. They're just your work, So one of them is called top-down coding, which means write, I'll put in quotes, write main first. Okay? And then there is bottom-up coding, write the smallest functions first. And these are two ways of working out a problem. There's more. You can do a little bit of top-down, a little bit of bottom-up. But there's a couple important concepts that I'm going to run you through that will help you do them. And in both cases, you would be like, but don't you need everything, right? Like if you're going to have main, call some function, that calls some function, that calls some function, that code won't compile until all those functions are written. Right, and so the new programmer's like, I just have to code everything, and then start debugging. And if this doesn't work and this doesn't work, there's some approaches, there's some tricks I'm going to show you today that will allow you to do these things without needing to code everything at once. Always, 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 you want to be working on a small little slice of program at a time. You're going to be working on one specific thing at a time. So if you're doing times table and you're just trying to get the row and column headers working, you want to be able to focus on that without needing to worry about all the rest of it working, And what we're going to do today is a little bit like times table. So this is a dice roller that we're going to make today for my favorite role-playing game, which is called Legend of the Five Rings. Legend of the Five Rings, which is a fantasy samurai role-playing game. I play a lot of D&D. I'm going to start playing Pathfinder again. Second edition Pathfinder. I think I'm going to start playing that again on Sunday. But Legend of the Five Rings is my favorite role-playing game for a variety of reasons. Food's here? Yeah, but I'm in lecture.
No, they canceled it.
They canceled the food. Oh. Postmates, I tell you. So L5R has a dice rolling system that was too complicated for my brain to figure out. Okay, so Dungeons and Dragons, you might have heard of this. Dungeons and Dragons has a very easy dice rolling system. You roll a d20. A d20 is a 20-sided die. and add a number to it. Okay, and if that number exceeds a certain number, you succeed. If it's below, you fail. So it's really easy to figure out your odds of success. Like if you're rolling a d20 plus 10 and the target number is 15, then you need to roll a 5 or better on a d20. So there's a 1, 2, 3, or 4 that will fail, so you have a 20% chance of failure. It's pretty easy to calculate. Okay, every +1 you get on a die roll increases your chance of success by 5%. It's pretty easy to figure out. Legend of the Five Rings uses a roll and keep system. Okay, and so what that means is you roll X dice and keep Y dice. Keep the Y highest. Doesn't have to be, but for this it will be. The Y highest dice. Okay? So if, for example, I rolled... I'll show you how this works. So Legend of the Five Rings rolls 10-sided dice. So let's say we're going to roll 6 dice and keep 2. So we write that as, if we roll 6 dice and keep the top 2, we write it as 6k2, like that. Okay. So how would I roll that in real life? I'd roll 6 10-sided dice, and I would keep the 2 highest ones. I would keep the 10, and I'd keep the 8. So that would be an 18. Okay. So on that die roll, I got an 18. Okay, let me roll it again. Let's see here. We got a 9 and a 7, so that was a 16. Roll again. 10 and a 10. It's a 20. 10 and a 10, another perfect roll. 20. Okay. 8 and a 7 is a 15, sorry. Do you guys understand? So I'm rolling 6 dice and I'm keeping the 2 highest ones. And I'm adding them together. I add the results together. So whatever the 2 highest numbers are, I add those together. That's my total. Does that system make sense to you? If I roll 4 and keep 2, then that would be a 17. This would be a 16 because I'm keeping the 2 highest. 18. So what do we do with these numbers? That tells you if you hit or not, right? So like, let's say I want to know what my odds are of hitting a 25. Right? It's like maybe that's a pretty common number for like monsters to have as their defense value. So if you roll your attack roll and your attack roll is 6, keep 3, which is pretty common for a beginning samurai, you would roll 6 dice, keep 3. This would be a 16 plus 7, so 23. That's a miss because I needed to get a 25 to hit. So let's roll again. So this was a 16 plus 6, 22, miss. 17 plus 6, miss. Here we got a 17, 24, miss. Okay. Here we go. That's a 28. So I got a 10, a 9, and a 9. So that would hit. Okay, a hit at armor TN of 25. Okay. Do you guys understand that? And the reason why I'm showing you this dice roll thing is because for a long time I couldn't figure out how to calculate what the average result would be. Right? I mean, I could roll 6 dice and keep 3, but I couldn't mentally figure out like, okay, what is the average number going to be on 6 keep 3? I can't do that in my head. Dungeons and Dragons, I can do it in my head, right? If I, if I'm rolling d20 plus 10 and the target is 20, I need to roll a 10 or better to hit. So it's a 55% chance of hitting. Okay. It's very easy. Every point is 5%. With this system, it's like, but what if I roll another die and it's lower than the current one? My brain just couldn't handle it. And I do have friends that are actuaries that do probability and statistics for a living, and they probably have some sort of equation that would compute the average value of something like this directly, but I don't know it. I'm a computer science major, And what computer science majors do when we don't know things is we brute force it. If we don't know, what the average number is going to be, we're going to roll these dice a lot of times and take the average result. So I'm going to roll 6 keep 3 a million times and then see what the average result is across a million dice rolls. Okay? So the when I took calculus, my calculus instructor was a engineer at General Dynamics, one of the biggest engineering companies in San Diego. He taught calculus for fun. And he told us, he's like, look, all this stuff we're teaching about integrals and derivatives and all that stuff, it's fine for like simple textbook problems. But in real life, these problems get so complicated we can't solve them by hand. Like there's not enough paper, to like kind of solve the kinds of things we need to do. So what we do is we approximate them. So if we want to see how much lift will be generated by a wing, what we do is we put the wing into a finite element modeling simulation and we blow virtual air over it and we simulate. We have the air randomly moving around, because it's kind of chaotic. And we have rules for physics on how these things behave, and we simulate it over and over and over again until we generate sort of an average amount of lift that will get off a wing at this angle of attack at this wind speed. Okay? And so people in the engineering world and math world, to a certain extent, and physics world, they're like, we don't know the answer to this. What are the odds that a water molecule collides with another water molecule? It's very complicated because there's all this Brownian motion and stuff going on, and they're polar molecules, so they have not an even electromagnetic field around them. And so as they move around sort of randomly, they move and interact in different ways. And so I have friends in the physics department when I was in college who did Monte Carlo simulations. Monte Carlo simulations are you just run it a bunch of times and just see what kind of average results you get. So that's what we're going to be doing today for this. I can't compute in my head directly what 6 keep 3 is. So what I'm going to do is I'm just going to roll 6 keep 3 a million times and see what the average result gets. Do you guys understand where I'm going with this? The purpose there is we want to just be like, it's too hard for my little brain to understand. So, okay. So how do we do this? Do we do it top down or bottom up? Top down, we write main first. Bottom up, we write the smallest function first, which would probably be like a D10 kind of thing. So there's a trick though to getting both of these to work. Okay, because we're going to have the structure of this is going to look something like this. Main we'll call Monte Carlo or something like that. Monte Carlo, which we'll call roll and keep a million times, which we'll call exploding D10, which we'll call D10. So these are the functions we're going to have to write. And if main calls a function called Monte Carlo and the function Monte Carlo doesn't exist, then it won't compile, right? This is the trap that I was talking about. New programmers think they have to write main and Monte Carlo and roll and keep and exploding D10 and regular D10. I haven't talked about what exploding D10 means yet. I will in a little bit. But there's 1, 2, 3, 4, 5 functions that all need to be written, and new programmers will try writing all 5 of them at the same time before compiling the code once, because you can't compile it until all of them are in, right? Because if I put main in here and main, calls Monte Carlo doesn't exist, it won't compile. So you can't test your code. Okay, so small first sounds better in this situation. You can actually do it either way. And I'll show you briefly how to do it top down, and then I'll do it bottom up. So to do it top down, so Monte Carlo we'll do, we'll make it like times table, right? So we'll say int size equal to 10 for int roll equals 1, roll is less than size, roll plus plus, that's how many dice we're going to roll. We're going to generate a table of results. We're going to generate, what we want to do is actually display a table of results for all possible values for roll and keep between 1 and 10. So we're going to generate 7 keep 2, and 8 keep 3, and 9 keep 7. We're going to do all of them. I'm going to come up with a cheat sheet, right? So after this program runs, I'm going to have a cheat sheet that I can print out and take to the table with me. And if people want to know what is the average value going to be if I roll 7 keep 2, I can look at it and be like, okay, it's 18, right? Because you can do things like spinning void points and things like that that will give you a boost on your roll. So if you need to get a 25 to hit, you're like, okay, if I boost it to 8 keep 3, then I'm probably going to hit, so I'll spin a void point, right? So people will have these references. In fact, I have one on my computer here. Role-playing games, L5R 4th edition. Roll and keep. There we go. So this is a pre-generated table that tells you what your odds are of getting a certain target. So like if you're hitting a monster with an armor of 25 and you're attacking with 6 keep 3, you've got a 52% chance of hitting it. But if you spend a void point, which you have a limited supply of, that will take you up to 7 keep 4, and that will boost your odds of hitting from 50% to 85%. So, you know, this is the kind of thing you can keep with you at the table and look at it, you know, to decide, you know, if it's worth it or not. If, however, you have like 9 keep 4 to hit, you already have a 95% chance of hitting. If you boost it to like 10 keep 5, it goes up from 94.8 to 95%. It's not worth spending the void point on it. You know what I'm saying? So I want to figure out how to generate this kind of stuff, you know. So for every combination of roll, all 10 values of roll, because you can't roll more than 10 dice. So it's a nice limitation in the system. So for every possible value of roll, for every possible value of keep, and let me know if you don't understand what these terms mean, because I'm going to be using them a lot. I'm going to roll 5 dice and keep 1. That means I'm going to roll 5 dice and keep the biggest one of those 5. Okay. Do you guys understand conceptually what we're doing here? And then, of the dice we keep, we add them together to get a total. So what I'm going to do is generate a times table, basically. So I'm going to maybe do like a row header, column header. Yeah, let's do a row header, see out, roll. And then we will see out the result of Monte Carlo for roll, keep, and let's say 1,000 trials, followed by another tab. And then at the end of the row, we're going to see out end line. And then we'll need some column headers on here. So okay, so I want to see if my formatting is correct. But this code won't compile. Why? Why will this code not compile? I'm basically doing, this is the times table assignment, except instead of filling the 10 by 10 times table with, you know, 5 times 4 or whatever, I'm filling it with the results of this function that doesn't exist yet, which will compute the average value of this roll and keep thing. Yeah, Monte Carlo doesn't exist yet. And so now this is where the new programmer goes, okay, now I have to write Monte Carlo. Oh wait, Monte Carlo's calling this one. Now I have to write this one. And you just kind of go down the rabbit hole. Watch this. I'm going to solve this chicken and egg problem. Top-down coding can solve the chicken and egg problem by using stubs. A stub function is one that just returns some fake but maybe plausible data. So I'm going to make a function called Monte Carlo that takes a number of dice to roll, takes a number of dice to keep, a number of times we should re-roll it to average it out, and it is going to return a random number from 1 to 100. Do you guys see why I'm doing that? That makes sense? Is this accurate? Is this the correct number? Am I done if I finish the assignment? What do you think? It's not done, but it's giving a number that's kind of in the, I don't know, ballpark. You know, most of these numbers are going to be somewhere between 1 and 100 or something, you know, so yeah, it's just going to return some sort of plausible value. It's a phony. It just returns a fake value. And I could just always have it return 10 or something, but I think random will make it a little more interesting, because then if some digits are bigger and some digits are smaller, I can see if the formatting is going to be right or wrong. So when you do top-down programming, what you do is when main is going to call a function, you just make a fake version of the function. That just, like a database query. How many customers do I have in the system? 7. Do you have 7? No, it just always returns 7. Do you guys understand? And now I can test to see if my table works. And it doesn't. Okay? Do you see what I'm getting at here? You don't want to like write this and then write that and then still have this broken. You always want to be focusing on a little slice of your program at a time. And if you're doing top down, you write main first. And then after you get main working, then you write Monte Carlo and you stub out the functions that Monte Carlo writes. And then after you get that working, then you go into that one and you work your way down. Okay, so what is wrong with my code here? Let me minimize my face. What did I forget? It's kind of looking almost okay. What did I forget? I forgot one little thing. Inline, yes. My top row here does not have an inline. Do this and run it. You can see, voila. Fixed. Do you guys see that? Yeah. So we're going to roll 1 die, keep 1 die. Oh, look at that. On just 1 die, we average 84. That's pretty good. But if you roll 7 dice and keep 7 dice and add all the results together, you only get 6, which is not possible. Right? Do you guys see why I did this? So it's just providing fake, phony data, and that allows my code to compile, and I can make sure my layout and all that stuff is all, it's all good. Okay? So if I'm rolling 1 and keeping 1, the average result on 1 die is 84, clearly. Are you guys with me on this for top down? Now I'm going to stop here and do bottom up instead. I'm going to show you the other way of starting a project. Okay, because this is the hardest thing for students. Is like, I've got 5 different functions to write. I don't know where to start, where to begin. Each individual part I could probably do. If you wanted me to make a random number from 1 to 10, I could probably do it. But it's this chicken and egg problem of like, I need to have everything done before I can do anything, before I can run anything. And this is why I'm trying to show you how to approach it, how to solve the chicken and egg problem. You know, you can't do main until Monte Carlo is done. Monte Carlo doesn't get called until main's done. You're stuck, right? So what you do if you're doing top down is you stub out your functions. At each level as you're going down, you just make fake phony functions that simulate the behavior of the function it calls, right? So, hey, what's up, Girl Chow? So I'm going to pause here, and I'm going to actually just comment all of this stuff out here, because I'm now going to show you what it would look like if I did it the other way. I'm going to do bottom-up coding now. Okay? And bottom-up coding, you start with the smallest function call, the smallest, easiest function call, which in this case is just making a number from 1 to 10. Okay? So int d10 takes no parameters, and it returns a number from 1 to 10. Do you guys remember how to do this? Rand modulus 10 plus 1. You guys remember that? To make a random number from 1 to 10? Rand will produce a number from somewhere between 0 and 2 billion. If you modulus it by 10, modulus is the remainder operator. Anytime you divide a number by 10, the remainder is going to be between 0 and 9. So it'll randomly generate a number from 0 to 9. We add 1 to it, so it randomly generates a number from not 0 to 9, plus 1, 1 to 10. And there are better ways of making random numbers, but none that are simpler to write. So there you go. But now I've got a problem. Here, let me comment out Monte Carlo, because you don't exist yet either. I've got a problem. And the problem here, it's the same chicken and egg problem, is that the function that calls D10, which is called exploding D10, which again I'll explain in a little bit, doesn't exist. So now I have to make exploding D10. But in order for that to be called, I have to make another right? So how do I solve the chicken and egg this way? You do it by doing something called a driver. So top-down coding uses stubs. Bottom-up coding uses drivers. What this means is that main doesn't do the normal main stuff. It just calls your function to test it. Okay, so rather than main doing all of this like formatting and like making a table and column, nope. Main, if I was doing bottom up, all that commented stuff there would be gone. It'd just be an empty thing. And all main's going to do is just cout D10. You guys understand? This is a driver. Okay. You guys see what we're doing here? So rather than needing all these chains of functions in between, main just calls D10. Hey, let's see if you work. You guys see this? I know you guys are always quiet on Discord. You can talk more. It's okay. it's allowed for you to talk on Discord. You're not interrupting me. Trust me. So what we do here is we just have main call the function. We're going to just see if it works. Okay. So g++ main.cc. See if it works. We got a 4. Cool. It works. Right? We ran it one time. That's good enough, right? Can you run it again? Sure. I got 4 again. It's random. I just got lucky. I'm going to run it again. It's just very, it's just, you never know with randomness, Yeah, so we need srand up in here, right? This is why we test our stuff, right? So srand time 0, like that. And now, if we run it, we get different numbers every time, right? As long as we don't run it too quickly, because time returns seconds, right? So if you run it multiple times within the same second, you'll get the same number. So as long as we are waiting a second in between each one, good. Okay. You guys cool with this? So now, now that we're like happy with it, I guess, I would, unless I'm going to be running the program twice in the same second, which I'm not, so I'm happy with it. Could you make time return something smaller than seconds? Yeah, there's like I said, there's better ways of doing all this stuff. The right answer is just not to use srand or rand at all. Is the right answer. So there is so if you want to do it properly, there's this class here called the uniform int distribution, and it returns a number in the range between 2 integers, and you can do it something like this. So you, like std : default _ random _ engine space generator std : uniform _ int _ distribution angle bracket int close angle bracket distribution parentheses 1, 10 is what I would put in there. And then you can call this like it's a function, passing in the generator, and it generates a number from 1 to 10 each time. This is the correct way of doing it. It's also perhaps not needlessly verbose, but it is verbose, and it is not short enough for first semester students to be able to remember it. This is short enough for a first semester student to remember. So that's why I teach RAND, not because it's good, but because it's memorable. You can memorize it. Okay. So, okay, so we got this. Now we need to talk about this exploding D10 thing. So what is an exploding D10? An exploding D10, well, in L5R, in Legend of the Five Rings, if you roll a 10, it explodes, which means you roll another D10 and add the results together. And if that one's a 10, you roll again and add the new die to it. So for example, if you're rolling 1, keep 1, you can roll a 10, and you get lucky, you got a 10, and then you explode, and you roll another D10. It's another 10. Cool. You roll another D10. It's another 10, and then you roll a 7. Well, your one die result was a 37. So you got a 37 on a 10-sided die, because it's an exploding D10. It would only happen 1 out of every 1,000 times. You triple explode like that, but it happens. And in fact, you know, given how often your characters are in combat, it's quite possible for peasants to kill your mighty samurai warrior by throwing a rock at you, and then they quadruple explode and kill you. And there's no raised dead in that campaign or game system at all. So you just die. Yeah. If the DM is really hot on the dice, they could just keep exploding forever, you know? The most I got was like 13 explosions on one. It wasn't on the same die, but it was on one dice roll. I was rolling like 8 keep 6, and I exploded 13 times on it, and ended up with a 100 and I don't know what it was, like 140 or something like that on 6 dice. It was ridiculous. Like I think I actually had to throw away one of my explosions because I exploded more than the number of dice I kept. So, like a spear and bowling, yeah, exactly, where you can get more than on the next set. You add your exactly, yeah, it's like a spear, right? Where you add your point total to the next set. Yeah, and if you do that again, like with a strike, you know, they keep kind of adding together. Yeah, it's a good analogy. Okay, so would this be like recursion? No, we don't have to call ourselves on it. We could probably write this using recursion, but I'm going to write this using a loop. So how many times is the die going to explode? Do we know or do we not know? So we're about to roll a d10. Do we know how many times in advance, how many times this random die is going to explode? No. So do we use a for loop or do we use a while loop? What you guys think? What's the right loop to use here? While loop. Good. Yes. Good. You were all correct. You're wise and noble individuals. So we're going to have to come up with some sort of variable that tracks all this, because we're going to keep rolling dice over and over again. So we're going to make a variable that will hold our current point total. And we're just going to have a while true loop here. And then after we finish the while true loop, we're going to return whatever sum we have. So let's do this. Int roll is equal to d10. So we're going to roll a d10, and we're going to add that to the sum. And then we're going to say if the roll was less than 10, break. So it's an infinite loop. It's an infinite loop that will break after we roll a number less than 10. Do you see that? As long as we keep rolling 10s, we're good. If we ever get a number below a 10, which is almost always, right, then it breaks. So 90% of the time it'll break. 10% of the time it'll continue the infinite loop. Do you guys understand the logic here? So we roll a d10, we got a 7. Okay, we add 7 to the sum. The sum is now 7. 7's less than 10, we break, we return 7. Easy. But if we got a 10, we add 10 to the total, We come up here and do it again. We got another 10. Oh, cool. We got a 20 now. Do it again. Oh, another 10. We got a 30 now. Roll the 7. Okay, the sum is now 37. Our roll was less than 10. Break out of the loop. Come down here. We return 37. Do you guys see how that works? So this is why I teach you guys, if you know how many times something's going to run, use a for loop. If you don't know how many times it's going to run in advance, use a while loop. That's how I mentally divide the system up. Down here we knew, right, because we're making a 10 by 10 table, right? We're going to make a 10 by 10 table like our times table. So we know it's 10 by 10, so we use a for loop. Right? Up here, we don't know. It's random. We're just going to keep rolling dice, and as long as we keep getting 10s, we just keep going. We don't know how many times to explode. Does that conceptually make sense to y'all? Today's lecture is covering everything that we talked about this semester. We got variables, we got functions, we got loops. We're going to have a vector in a second. Everything this semester is encapsulated in this one 1 hour long lecture here. Okay. So conceptually, do you understand what's happening here? Cabrera, Marquez. Yeah. So what do I do next? What's my next step? What's my next move? You guys tell me. What's my next move? Order DoorDash? Probably. Can't believe they canceled the order. It couldn't have been DoorDash. My wife orders on Postmates a lot. And Postmates has this really annoying tendency of just like, nope, click. You sitting there waiting for your food for an hour. You check it. No, order was canceled. Postmates trash, yeah. So what's my next move? Besides ordering food. What's my next move? I've got this function done. I've got this function done. Let's see, main calls Monte Carlo, which calls roll and keep, which calls exploding D10. So what's next? Do I write roll and keep next? Check it. Very good. That's exactly right. Yeah. So my next thing is not to just move on. I need to make sure this thing works right. You know what I'm saying? So I'll call this exploding D10. You see how the driver works? I know the D10 works now, so I'm just going to have main call exploding D10. I might even, do a few of them, just to see. There we go. There we go. Oh, look, there's an explosion. Okay. All right. Okay, let's see if we can get some double explosions up in here. Maybe a triple explosion if we're lucky. No. A double explosion's 1 out of 100 chance, right? So our driver can, work it a little harder, right? Make 30 at a time. Damn. Not a single explosion on 30 dice. Look at that series of ones. Man. Yeah, the last time I played a game of L5R, I rolled 4 keep 3. So I rolled 4 10-sided dice, and I kept 3 of them, and I got a 6. There's 1, 2 explosions. Come on. There we go. There's a double explosion. Okay. There we go. We'll get a triple. Oh, a lot of explosions on that one. Seems about right, I think. About 1 out of 10 are an explosion. Okay. All right. So good. What's next? And again, if something went wrong, then I would come up into here and see out each roll. I would see out the sum each time and verify that my logic's working correctly and things like that. So what's my next move now? I'm confident D10 works. I'm confident exploding D10 works. I was seeming to get pretty unlucky there, so I don't know. 0 explosions on 38 dice rolls. It's pretty bad. Yeah, I think it's not Monte Carlo time. The function that's going to call exploding D10 is roll and keep. So now we're getting to the heart of the matter. This is the hard part, okay? So roll and keep rolls X dice and keeps the top Y and adds the kept dice together and returns that value. Okay, so we're going to make a function called roll and keep. It takes int number of rolls, int number of dice to keep, and this has a parameter. The other two didn't have parameters, so we need to vet our parameters. Okay, so what values would be illegal for being passed in from main? Main is going to be calling roll and keep. What values passed in for rolls and keep would be, maybe I'll just call it a roll. What values could I pass in for roll and keep that would make no sense whatsoever? That would be bad. That would be worthy of death. Death! Negative values for sure. Something has gone horribly wrong if I'm asking you to roll -7 dice. You know what I mean? Like, because I'm writing main, and so if main is telling you to roll -7 dice, main has had a stroke or something, you know what I mean? Like, not saying it can't happen, but if it does happen, we need to die. Okay? And so there's actually a standard library function that is die. Like, you know how in all of our homework assignments, if the user types in squirrel, we call die. There's actually a standard library function that does that, and it's called assert. Okay? There's also static assert, but let's not worry about that now. So assert is like a die function. So we are going to assert that roll is greater than 0. So I think 0 doesn't make sense either. Roll 0 dice. Maybe. I don't know if that's bad or not. Maybe it's only really bad if it's negative. Maybe I'll do that. So I'm going to say assert roll is greater than 0. I'm going to assert that keep is greater than 0. This is a function, something that looks like a function, that exists in CAssert. So CAssert is a header file that gives you the assert function here. And all it does is say that if roll, what this means is if roll ain't greater than or equal to 0, die. Okay? And it's a die function that is already made, and it's actually better than our die function, because I'll kill it in a second, and you'll see. So in the meantime, let's just return, I don't know, 42 or something. So let's test it. We have a driver. Let's test both of these things and make sure that it is dying properly. So I'm going to pass in roll and keep. I want to roll -100 dice. Okay. And when I run it, I get, boom, assertion failed. Okay, so this is the result of the CAssert assertion function. It tells you the program you're in, a.out. It tells you the file you're in, main.cc. It tells you the line that it died on, line 41. It tells you the function you died in, int roll and keep, where it takes in 2 ints as parameters. And the error message is assertion roll is greater than 0 failed. That means you passed in a roll below 0, right? Because when you assert that the number is above 0, then you're, if that's not true, it kills it. Okay, yeah, it's really nice. I don't use this on my homework because the auto grader will barf on that. Because your file might have a different name, your line number will probably very certainly be different, and so I can't auto grade on this. And so I use a die function that just prints out bad input and quits, so that the auto grader can check that you're vetting the input properly. But for real software, we actually use assert. And you know how, like in the past, I've told you, like, professional programs don't just quit if something bad happens. That's not exactly true. Bethesda in particular is famous for having a dialog box that just says assertion failed. So you're just like playing Fallout New Vegas, bloop, assertion failed, and then it kills your program. So if you've ever played a Bethesda game, you've probably seen something like this. Program Emily's Miracle of Life Deluxe, delicious 15.exe. line 653. And Bethesda games, they strip all the debugging information out before they release it. So it just says assertion failed 0. Cool. Absolutely useless error message. Thank you, Bethesda. Very cool. So they have a lot of Battle of Bethesda Church. That's funny. Huh. Yeah. So if you've ever played Bethesda games, you've probably seen assertion failed errors before. So some professional programs do use it. They're not supposed to happen in practice, right? Because assertions aren't. They're not really supposed to be used for like vetting user input and things like that. Like if the user types in a bad name, you're not supposed to like assert that their name is Bill or something. Assertion is for you checking your own inputs. So like main is calling this, -5. Assertion keep failed. Like it's you checking you is what assertions are used for a lot. So now that our driver has verified this works, let's go ahead and see out the result of roll and keep. Let's roll 6 keep 3. And I've got a stub pretty much right now, right? It's printing at 42. So we need to now, and you can do that. You can actually go back and forth between like making a driver, making a stub, going a little top down, a little bottom up, So now we need to actually do the hard work. So we want to roll 6 dice and keep the 3 highest ones. Okay? So what data structure, what variable do we know that is capable of holding multiple integers of arbitrary size? We could theoretically use an array, but we're not going to use an array. Arrays suck. So we're going to make a vector. We're going to make a vector named vec of size 0. And how many times are we going to roll dice? Do we know how many dice we're going to roll when we're within this function? Is it passed to us how many dice we're going to roll? Yep, we know. That variable right there is how many dice we're going to roll. So in this function, we know how many dice we're going to roll. They're telling us roll 7 dice, roll 8 dice, roll 2 dice. Okay. So for loop, right? Print I equals 0, I is less than roll, I plus plus. We're going to roll some dice. So int okay, so let's make a, I don't know, die roll or something. Okay, so we're going to roll the die. So we're going to get 1d10. So, if we say roll 7 dice, okay, let's roll 7 times, we're going to roll a die. Exploding die. How do we add this to the vector? Which function adds it to the back of a vector? Push back, very good. Vec.push back, die. I feel a little nervous having die there because I'm so used to die being the death function. So we're gonna, yeah, whatever. It works fine. So we're gonna roll, and we get a 7. Okay, so we put 7 at the end of the vector. Roll it again. Got a 34. Okay, put 34 at the back of the vector. Roll it again. Got a 1. Put a 1 at the back of the vector. We do this number of times. Roll number of times. Okay, and so I'm gonna stop here and just debug it. Right. So for int x vec cout x. So I'm just gonna print the vector and just see what we get. Okay. Let's make sure that everything's working properly. 1, 2, 3, 4, 5, 6, and then it prints out 42 from main. Okay. Okay. We're getting explosions in here. There we go. There's an explosion. Okay. So, cool. We're generating the rolls properly. Now we need to keep the 3 highest. So how do we've done getting the maximum value from a vector, but the vector's not sorted. If it was sorted, it'd be really easy, right? Like if we wanted to get the 3 biggest values out of the vector. If it was sorted, we could just like grab element 0, 1, and 2, right? For loop, grab the first 3, add them up, return the value, done. But it's not sorted. So how do we grab the top 3 values from the vector here? What do you guys think? This is the hardest part of this assignment, which is an assignment. Are you not allowed to use sort? You can use sort. Why not? I never said a golden retriever can't play basketball. You want to use sort? I mean, that'd make life easier on us. Okay. Yeah, sort is smallest to largest, right? So if we did this, sort vec.begin, vec.end. Don't write your own sort functions, by the way, please. Just call sort. Yeah. So if we printed out the vector now, then you'll see that they're sorted from least to greatest. So we could write a for loop that goes backwards, right? Or we can sort it from greatest to smallest. Do you guys want to learn how to sort it from greatest to smallest? Look it up on Stack Overflow. Like a real programmer does. Yeah, I'll show you. There's an easier way than this, but this is the way that I remember. What this is return. This is something called a lambda function, which you'll learn about in CSI 41. But there's a third parameter you can pass into sort that tells you how to compare the elements. By default, it sorts least to greatest. If A is less than B, it returns true. This one I'm returning true if B is less than A. So it's going to return true in the opposite of the normal case. Don't worry about the syntax. I'm not going to teach it to you. If you want to look at the cleaner way of doing it, you can Google it and find it on Stack Overflow. This is the way that I do it. So this, if we run it now, it will sort from greatest to smallest. Okay. So now we're in the home stretch. That was the hard part, picking out the 3 biggest ones. Now we're in the home stretch. Now we just need to add up the first 3, the first keep elements. Sum is equal to 0. Return sum. So what kind of loop do we use here? If we're going to add up, and we know how many dice we're going to keep, right? What do we use? While loop or for loop? For loop. Okay. If you insist. What do you guys think? So if keep is 3, it's going to add to the sum vector.at 0, then vector.at 1, then vector.at 2. So it's going to add the first 3 elements in the vector, which are the 3 biggest ones. Problem solved, right? Anyone see what the problem is? There is a problem here. There's a very big problem here. There's in fact a crashing problem here. What could cause this to crash? Let's try it first. Let's try running. Okay. Let's compile the code, run it. Did I get rid of the... Dang it, I should probably stop taking this stuff out. I've rewritten this 3 times now. So for every element in the vector, see out that element in the vector. So the top 3 elements are 18, 15, and 8, which is 33 plus 8, which is 41. We're getting 41. Run it again. 9 plus 8 plus 6 is 17 plus 6, which is 23. Run it again. 22 plus 7 is 29. Okay, the code works fine. But Professor, I thought you told us there was a crashing problem here. There is. Where is it? What condition did we not think about? What condition did we not think about? There is one more precondition up here that we overlooked. What is it? What bad input, let's say, could we pass in from main and will be passing in from main? Out of bounds check, yeah? There will be an out of bounds. When will an out of bounds occur? In fact, I'll tell you, this is going to go out of bounds. Under certain circumstances. What circumstances could cause that to go out of bounds? Speaking of which, the Loops Competency Exam Take 2 is up. When does a loop go out of bounds, right? When the value is bigger than the size of the array. When would it be possible for keep to be bigger than the size of vec after it's done roll pushbacks? If keep is higher than the roll. Yes, exactly. So if we were to switch this around and say roll 3, keep 6, crash. Right? Because we're trying to keep the first 6 elements of the vector, and there's only 3. Crash. Okay? And this code here is trying to generate all 10 by 10 possibilities, which includes 10 keep 1 and 1 keep 10. 5 keep 2 and 2 keep 5. Half of them will cause a crash. So, how do we handle it? What's the best approach here to handling it? I can tell you what L5R does. L5R does this. They say if the number of dice rolled is less than the number of dice kept, then the number of dice kept is equal to the number of dice rolled. So if you roll 3 keep 6, it turns into 3 keep 3. That's how the role-playing game does it. Make an assert function. If you do an assert function, then it will crash when you try doing this in main. Which is not what I want. I don't want to make main any more complicated than this, right? So how would you do it? If I say roll 2 keep 5, I don't want it to crash. I just want it to work, to look nice. What would you do? How would you handle that? What would your approach be? There's no right or wrong answer here. You could have it assert and then have main not generate those values or something. That's fine. Put a little if statement into main. That's fine. But Odal's approach would work just fine. In fact, if a user inputs a value greater than roll, the user's not inputting anything in this assignment. It's all generated just by the computer. I'll tell you what I would do. I would just return 0, because this is actually a program that I wrote for myself. Because I played a lot of this role-playing game and I wanted to figure out what the average dice rolls were. And so when I was making this for myself, I just said, if the number of dice rolled is less than kept, return 0. And the reason for that is because then half the table will just be zeros and I can just ignore them. Because if you did what I had there before, you would end up getting all the same number across. 1 keep 1 is the same as 1 keep 2, which is the same as 1 keep 3, which is the same as 1 keep 4. And it just kind of fills the table with extraneous data. So what I did was I just had it return 0. And I think I had it draw a hyphen or something, like if a 0 came back, it would just not print it or something so that it would kind of look nice. But that's my approach. Yours might be different. I'm not saying mine's right. It's just a decision. Okay, so so if we do this, test it, got a 0, cool, no out of bounds. Okay, so now we need to do Monte Carlo. But before we do Monte Carlo, let's just see what we get if we do this. So let's put our thing back in place here. And rather than doing Monte Carlo, let's just fill this thing with roll and keep. So for each combination of roll 1, keep 2, roll 6, keep 5, for every combination we're going to generate a table that has the values of a single roll of it. And it looks horrible. Why is it horrible? Because I left in these COUTs here too. So I'm going to search for any other COUTs. Good. Okay. And there we go. So you see how the zeros kind of make it look nice? That's why I did that. Okay, so we can see here 1, keep 1. We got a 1. Roll 2, keep 2. We got a 10. The numbers down here, roll 9. Oh, we should go up to 10, though, shouldn't we, huh? So that's a problem. Again, you're always wanting to just work on one slice of your code at a time. You never want to be juggling 5 different balls at the same time. When you're working on roll and keep, you want to work on roll and keep and nothing else. When you're working on main, you want to work on main and nothing else. Do you understand? This is how you make computer science go smooth. Okay, and that needs to be less than or equal to as well. Okay. Yeah. Right. So. There, got the formatting all looking good now. Okay, so we're going to roll 8 and keep 3. We got a 34. So are we done? If we roll 7 and keep 5, we get a 62. If we roll 8 and get a 5, we get a 32. That doesn't sound right. Shouldn't the average number for 8 keep 5 be bigger than the average number for 7 keep 5? And shouldn't the number for like 10 keep 9 be even bigger than this one? What are we missing here? Right now, for every 6 keep 3, 7 keep 4, we roll it once and say that's the average result. Technically is for one number. So what do we need to do? We got 2 minutes left. How do we do this? The simulations. Very good. Monte Carlo time. All right, we're going to just make a function called Monte Carlo. Boom, Monte Carlo. And this function here is all the way up here somewhere. Yes, there we go. Delete U, D4D, drop down here. So Monte Carlo is just going to call roll and keep a bunch of times, right? So for int I equals 0, I is less than trials. Trials is how many times we're going to average it together. I plus plus. Int sum equals 0. And I'll probably want to use a long for this one just to avoid overflow if we do too many of them. So we are going to just call roll and keep. Passing in roll, passing in keep. So just over and over again, we're going to roll it and roll it and roll it and roll it 1,000 times. We're going to roll them all together, add them all together up into sum, and then we're going to divide it by that number. That's how you do an average, right? If you want to average 10 numbers together, you add 10 numbers together, then divide by 10. So we're going to return sum divided by trials. So 1,000 times, we're going to add the random rolls together, and then we divide by 1,000, and we're done. That's it. That's the entire thing. So Monte Carlo simulation, 1 minute, out the door. 2 minutes now. There you go. There's your answer. So that is the average dice results for 1 keep 1, 3 keep 2. If you want to get more precision in it, we can add more zeros to the number here. So rather than 1,000 trials, we can do 100,000 or 1,000,000. And so if we do this, we run it, and you can see it thinking, right? Because for each one of these things, it is doing it a 1,000,000 times. And for each one of those 1,000,000 times, it's pushing back into a vector and sorting it and picking out the biggest ones and adding them together and reporting that back and adding that to the total, then doing it again 1,000,000 times for each one of these numbers. But you know what? Who cares if it's slow? Because all I need to do is run this program once. Once I've run this program, I can just save this to a notepad, or put it into a PDF, and I'm done. Until the game system changes, I'm done. That's it. Or if I ever want to add more features to it, because sometimes when you make rolls, they explode on 9s and 10s, or they explode on 8s, 9s, and 10s, and that's exciting. And then there's another rule that allows you to re-roll 1s, and so there's a lot of, little fiddly bits in there that you can add to it. But basically, it doesn't matter that this program runs slow, because you're not running it in real time. You run it once. I have a lot of programs in my professional career that I run like once a year. And I could speed them up, and I don't. Why? Because I run them, it takes 15 minutes to do all these very complicated statistical calculations. I hit run, I go to Starbucks, I get a cup of coffee, I come back, it's done. It would take me a day or two to make it faster. Not really a whole lot of work. But at the same time, like, when you run something once a year, like, there's really no need for it to be any faster than that. And so this program here took a little bit of time to run, but this is a pretty accurate result. So if you want to find out what the average result of 10 keep 5 is, it's 44. And so if you're like playing with your friends and your friend has a 6 keep 3 attack, you'd be like, okay, on average you're going to get a 26. You're on average probably going to hit that bad guy. It's like, okay, what if I spend a void point to go up to 7 keep 4? Well, the average roll then would be 33. And that other table I showed you actually gave the percentages of beating a number, which is a little different than this. But this tells you instead the average results. So you can look at this and kind of see, if I'm 8 keep 5 on a roll 8, keep 5, on average I expect to get about a 40. Okay. So that's it for today. Did you guys learn something useful about solving a problem that has multiple chunks to it? You can either work down, work up. How an experienced programmer will split a problem up. You break it into pieces, you break it up into little pieces, and you solve each piece. You solve each piece and test each piece thoroughly. And you don't move on until you're confident that part is working. And if you get stuck on a little part, like how do I sort a vector? Then you go onto the help center and you go like, how do I sort a vector? And people are like, sort vector.begin, vector.end. Okay, well, how do I sort biggest to smallest? And then somebody will answer it. And it's easy to get stuck, especially when you're beginning. There's a lot of things that can be done that you don't know how to do. But if you put them into small pieces, you can usually identify exactly the line that's giving you trouble. Like, I don't know how to sort this greatest to smallest. Google it, post on the help center, ask me, ask the TAs. And then you get unstuck, and then you can keep working. So just work on a few lines of code. You saw it. Every 3 or 4 lines of code, I'm saving it, I'm compiling it, I'm running it, I'm testing it with different numbers. 6 keep 3 and 3 keep 6 and negative numbers. And I didn't test with zeros, but I probably should have. So, you like working big to small? Yeah, it just depends on your personal preference. Do you want to go top down? Do you want to go bottom up? A little bit of both, like I did today. I kind of wrote main and then pretended I didn't, but then at the end I put it back in. And so you can kind of work on the problem from both ends if you want. Just always be working on just a little slice of code, just this much code. That's what the sand means. That's like on that much of the screen. That's how much you should be focused on. You should be confident everything else you wrote is correct and works and is bug-free. And you just are, with a laser-like intensity, focusing on like 5 lines of code or 10 lines of code, something like that, testing it thoroughly and making sure that it works. And then moving on only after you're sure it works. And then you end up with something cool. This is actually useful. I actually wrote this program for my own personal benefit. This isn't even like some cheesy demo. It's like I actually was curious because I couldn't figure out in my brain what these numbers were. So I just wrote a program to simulate it. Okay. So that is it for today, everyone. And we will talk more about the RPG on Friday. So collaborate with your partners, keep working on it. Take the competence exam if you need to. And I'll see you guys on Friday. All right. Peace out.